Ionization energy is the amount of energy required to remove an electron from an atom. It refers to the energy needed to overcome the attraction between a negatively charged electron and the positively charged nucleus. Generally, the outermost electrons, which are the electrons in an atom's outermost shell or energy level, also known as valence electrons, are the easiest to remove because they are less attracted to the nucleus and thus require less energy. In an atom of 3 valence electrons, the energy needed to remove the first outermost electron is called the first ionization energy. Once this electron is removed, the atom now has a positive charge. Removing a second electron requires more energy because the remaining electrons are drawn more strongly to the nucleus. The required energy is called the second ionization energy, and it is higher than the first ionization energy. The same applies to the third ionization energy, the fourth, and so on. Each successive ionization requires more energy as more electrons are removed, and the remaining electrons are closer to the nucleus. For example, it takes 2,393 kilojoules per mole to remove the first 2 electrons from aluminum, but much more energy is required to remove the third electron. This is due to the electron configuration of aluminum. The first 2 electrons are removed from the outer 3s subshell and the third from the 3p subshell. However, the fourth electron must be removed from the filled inner shell of the neon configuration, more specifically from the second shell. However, since the second shell is closer to the nucleus than the third shell, the attraction is much stronger, making the fourth electron harder to remove and requires a large amount of energy. Ionization energy follows certain trends on the periodic table. The ionization energy generally decreases as we move down a group in the periodic table. This happens because the atomic radius increases and the outermost electrons are farther from the nucleus. As the distance increases, the attraction between the electrons and the nucleus weakens, making it easier to remove electrons. In contrast, ionization energy increases as we move across a period from left to right. As we move across a period, the atomic radius decreases because the number of protons increases, pulling the electrons closer to the nucleus. This stronger attraction makes it harder to remove electrons, and thus, higher ionization energy. Thank you for watching and see you in the next video.